Hi everyone, welcome back to the Coding and Analysis YouTube channel. And in this video, I'm going to run a train test and split with a random forest regressor from a machine learning model to determine the 2025 fantasy football PPR um, points for the NFL players. And as you can see here, the previous video, I had to convert these three columns. They were objects, and I needed to convert them to numerical columns. So down here, I run a for loop to this Python list right here called numerical columns, and then use the PD pandas dot to underscore numeric method to change these columns to numeric numbers. So once I do that, I'm ready to create the function. So we call it train and predict. And then we start off with def, and then train underscore predicts could be the name of the function, and the parameters are going to be position and features. So what this function is going to do is it's going to filter our data set for one position. You can see here fantasy position equals position up here, and it's going to be wide receiver, or it's going to be running back, wide receiver, and tight end combined, and quarterback. And then we're going to train a random forest regressor model and evaluate it using a train test and split. And then we're going to return predictions for those two subsets of data, the train and test split data. So we start off with the filter data for a specific position right here. So like I said earlier, we're filtering the master data set, which is named combine underscore stats, for rows matching the desired NFL position. So running back, combine, tight end, and wide receiver, and the quarterback. And then we do a dot copy to avoid modifying the original data frame in memory. And then you see here this, we're just saying if the data is empty, we're going to print out this error message. But I made sure that all the data in this position underscore data in this data frame, that it's gonna have there's no empty cells in the CSV file. So we go next. The next step, we do the prepare the X and the Y. So the X is gonna be the feature importance columns, and then the lowercase y is going to be the target variable, which is the 2025 PPR column. And so with that, and then anything, if there's any NA or NAN, we're gonna fill that with 0. I don't think there's any NA or NAN figures in the spreadsheet. So then we reset the index. So here we're just ensuring all data is aligned on the same integer-based index of 0, 1, 2, 3 before we 0, 1, 2, 3, and so forth until we get to the final player in the index before performing the split. So we're just preserving the alignment right here by resetting the index. So in this case, if you were to add a column or delete a column, you would need to reset the index, or if you're deleting rows, you need to reset the index. But since we didn't do any of that, it's just more really a formality to for us to put this down here. And then so now we're splitting the data into train and test sets. So we're performing an 80-20 train test split using the train underscore test underscore split right here, which we brought that in from this model underscore selection skwarn package. So we're importing train underscore test underscore split. And then you can see here, we're saying we want the test size to be 20% and the training to be 80%. So when when we're returning this, it's going to return not just the X and Y splits, but also the row indices of the original position underscore data frame. So it's doing the actual row indices. So that's what that's going to do, is it's going to enable us to tag which rows were used for the training and testing. So it's going to be able to mark that in the rows. So we'll see which players are set as the training and which players are set as the testing. And then when we're doing this label split using the true indexes, so we're adding columns to the position underscore data data frame, indicating whether each player was used in the training or test set. And then you can see here the index train, index test. So this is where we're labeling it onto the data frame. So you can see here this position underscore data. It was originally combine underscore stats, but we changed it to position underscore data so we can filter on the positions of the NFL players. So just have to keep that in mind, that the position underscore data is the data frame that we're working off of. And then now we train the random forest model. So we're using we're just using abbreviation RF for the random forest regressor, and the number of estimators is 100, max depth is 10. So I guess we just think of it as like we have 100 trees, and then the we're learning 10 on the depth of 10 on those trees, and then we're using a random state for reproducibility. And typically, if you had more than like 1,000 or like 500, you would result. You would use 200, the number of estimators, and the max depth of 20. But since our figures are smaller, it's only like, let's go back and look at the figures again. It's 154 for wide receivers, tight end, 89 for running backs, 38 for quarterbacks. So, I guess you could see with the quarterback with being my 38, it's probably going to be more volatile compared to the running backs and the wide receivers and the tight ends. So then we'll do this rf.fit method, and what we're doing here is training the model on the training subset. And then, so going back to that, we just think of this as 100 trees and a max depth of 10. So just think of it as, you're going 10 feet up into the tree or whatever. Or if you're doing 200 estimators, that'd be 200 trees, and the max depth you'd be going 20 feet up into the tree to train the model. And then we evaluate the model performance by creating this y underscore pred underscore train and then y underscore pred underscore test. And then what that's doing here is it predicts the PPR points for the training and test sets using the trained model. And then the next thing we're doing is we're printing the mean absolute error for both subsets. So the mean absolute error is a standard regression metric to measure the average prediction error in absolute terms. So what that means is we're going to see the how far off we are with the actual so y, I guess you could say y underscore train is the actual PPR 2025 PPR column that we got from the CBS Sports site, and the Y pred train is the for it's going to be the training data that the model used all those. They're using all these feature columns to help determine that, and then we're going to find the difference, the difference between these two, and then we're going to print out the results for the training MAE and the testing MAE. So this is the actual 2025 results, PPR results right here, and then this Y-pred test and Y-pred train are the X feature columns that we use to help determine the model, help to determine the PPR scores for itself, and not for the So this is the actual column, and this is the model's predictions right here. And then for the feature importances, we're doing the Random Forest Regressor, or the abbreviation RF.feature importances, and then we're sorting by the highest. So the most important feature importances will be at the top, and the lowest will be at the bottom. And then, so what this is going to do is it's going to help us understand which variables are most useful in making the predictions, or the 2025 PPR predictions. So this, if we go back, so this is just going to show the difference between the actual 2025 predictions and the model's predictions. So we're going to see the differences in the training subset and the testing subset. And so we're going to print that out, and then we're also going to print out what the feature importances were that the model used to help to determine this predicted 2025 PPR number that the model predicted. So the next thing is the store the predictions for the correct subset. So we have a train underscore df data frame and test underscore df data frame. And so what we're doing is we're creating two separate data frames, train for the training predictions, test for the test predictions, and then we're adding the predicted fantasy football, the fantasy points, and the data split levels labels for clarity. And what that's going to do is we return this, and then we're combining all these predictions into one data frame. So combining all these predictions one data frame, and then from there we can we can see the feature sets that we're going to use. So when we return this, the training results and the testing results, this will be the end of our function. So this is train underscore and underscore predict. This is the end. And now we're using these parameters right here. So the position is it's going to be, running back, wide receiver, tight end, or quarterback. And the features are going to be all these columns that I did a walkthrough in the first video. So running backs. So these are basically, we're using the same here. We're using same columns for both the running back and the wide receiver, tight end features. And then we use like their age. I think we're just using the 2025 age for the players. So we're using like the health grade for the players for the upcoming season, for the health grade for the players, and then the adjusted risk and the projected role of the players that they're going to be starters or backups. And then the quarterbacks, it's a little, we're not using the receiving or receiving yards or receiving touchdowns. We're just using the passing columns and the rushing columns and the health grade, 2025 age, the adjusted risk, and predicted role. And then you can see here we're saying, use this function, train and predict function, and we're using these as the parameters. And then we're combining, concatenating all of these, and then we're rounding the results. It's going to be 2 decimals right here. So we have running backs first, wide receivers tied in second, and the quarterbacks will be third in this all underscore predictions at data frame. So we will just remember that this all underscore predictions is the data frame that we're looking at now. And then this is just a override dictionary. So Tank Dell, we're just saying we're looping through this dictionary right here that we created just to say that he's gonna be out for the season. It's not gonna score any points. And then you can see here in this for loop, predicted fantasy points we're going to override the points to 0, and then the note is going to be out for the season. And then we save the projected data to this new CSV file, and then this could be the output path, and this all predictions data frame. This is what we're going to show in the CSV file. So player data split, fantasy position, predicted fantasy points that the model determined, and then the actual 2025 PPR points that I got from the CBS fantasy football sports site. So you can see the this method 2 underscore CSV. So that's how we're creating this CSV. So we run it. We'll get the this MAE score for the training and the testing, like we talked about up here. So we're getting the train mean absolute error, the testing mean absolute error, and then we're getting the feature importances as well. So you can see here, the points. It's not too far off from the 2025 PPR from CBS. So for the running backs, it seems not too far off, so that's pretty good. by points. And you can see here the feature importance is it's going to be heavily on off of the 2024 stats, and then 9.7% for the projected roll. And then you can see here there's also the receiving catches, and then the receiving touchdowns, and then the health grade down here. And you can see the 2023, it's not really factoring in that much. And then we're looking at the training MAE and testing MAE, not too far off as well, just like the running back. And you can see here receptions is very high. So for the wide receivers and tight ends, that's basically 70% of the feature importance right there is the number of receptions for the players. And then receiving touchdowns is only 5.3%, and 2023 receptions is 5.2%. And then the projected roll, that's only 1.6%. So you can see there's a sort of a difference between these feature importances for the running backs and feature importances for the wide receivers and tight ends. And then you can see here for the quarterback, it's higher, 71 points off with the testing MAE compared to the training MAE, which is only 17.9 points off. And you can see here the feature importance is the most important. That's kind of interesting. It's the projected role of the players, if they're going to be a starter or a backup. And then 2024 total touchdowns is 19.9%, and rushing yards is 10%, and 2024 passing touchdowns 6.5%. The health grades 5.6%. So that's all interesting to look at those results. Look at the MAE and the feature importances. So in the next video, I'm going to look at this CSV file and then run do a evaluation on the R-square score and the mean absolute error score by position for the so it's going to be both for the training and the testing, and then I'm going to separate it out just to show the R-square and the MAE just for the testing data, and we'll see what the results are. So I'll do that in the next video. So thank y'all for watching. Always remember, never stop coding, and see y'all in the next video, and bye now.